Good afternoon, everybody. Welcome back from lunch. Hope you got outside, maybe went for a walk. Welcome back to the 2020 Wisconsin Lakes and Rivers Convention. You have walked into the Ecology Life in Around Our Waters stream. Hopefully that's what you were looking for. And this afternoon, I'm joined by Melinda and Melissa, who will be helping run the machine behind the curtain. And I'd like to introduce our first speaker today, Joseph Kabajczyk. He's the fisheries biologist for the Wisconsin Department of Natural Resources. Joseph is originally from northeastern Wisconsin. He obtained his Bachelor of Science degree in Fisheries and Limnology from UW-Stevens Point and a Master's in Science degree from Northern Michigan University, where he studied the interaction of brook trout with non-native salmonoids in tributaries of Lake Superior. Joseph worked for the U.S. Fish and Wildlife Service for 3 years in Michigan prior to becoming a fisheries biologist for the Wisconsin DNR in Eau Claire in 2014. And Joseph's presentation today is entitled Unique Fish of the Chippewa. Joseph, thanks for joining us, and it's all yours.
Well, thanks a lot, Bob. This is meant to be kind of a fairly laid-back presentation here. I'm just going to kind of go over some of the species we routinely see on the lower Chippewa River. Some of these species you guys will probably be very familiar with. Others may be new to you. And also, thanks a lot for joining. I know we're kind of late in the conference here, second to last talk, so I appreciate you guys sticking around and listening to this. Kind of had this split up into three different segments. First off, like I said, I got quite a few species that we'll go through that we routinely see on the Chippewa River. Then I'll get into some of our kind of more in-depth research projects with shovelnose sturgeon and lake sturgeon. All right, looks like technical difficulties on my end here. So I am attempting to advance the screen. There we go. All right, just to familiarize ourselves with the area. If you can see my pointer here, please let me know if you can't. But kind of in the middle of the screen is the city of Eau Claire. The last dam on the Chippewa River, prior to it free flowing for 60 miles all the way down to the Mississippi River, is located in Eau Claire. Upstream from Eau Claire, there's 6 dams in fairly rapid succession on the river. In about a 30-mile stretch, there's 6 fairly large dams. The largest impoundment on the lower Chippewa River is Lake Wissota, which you can see in the upper right-hand portion of your screen. That's a 6,300 acre impoundment. And the dam for that is just right at the top of your screen at Etcham Falls. So we'll be talking about that location as well in this talk. We can see another river coming in on the left-hand, kind of the left central portion of the screen, coming down from Lake Mahnomen, and that's the Red Cedar River. Just downstream of the confluence there is the city of Durand. And additionally, this section of the river here is called the Meridine Slough, and I'll be discussing that location as well. All right, so a little background about the fisheries in the lower Chippewa River. During FERC relicensings of the dams on the lower Chippewa River, there were some fairly extensive fisheries surveys that were conducted in the early 2000s. Basically, the lower 60 miles of the Chippewa River was surveyed from Eau Claire, from the city of Eau Claire downstream in the spring, summer, and fall. Many different gear types were used, which enables the ability to collect a variety of different species. So during this survey, there were 65 different species captured. I mean, that's kind of astounding to think about. You think about a lot of your local lakes, if you go fishing, maybe you catch, 3, 4, 5 different species in a day, and that's, fairly high diversity in your fishing outing. And you think that lake may have 10 or 12 species in it. Um, but we've verified at least 65 different species in the lower Chippewa River. There's 9 species of state threatened, endangered, or of special concern. We'll chat about some of those. The index of biotic integrity came back as excellent for the lower Chippewa River based on its very diverse fish community. However, there's a substantial decline in the shovelnose sturgeon population that was observed in the early 2000s. But we do have some encouraging results from a survey that we conducted in 2019, which I'll talk about later in this talk. So some sampling that we routinely do on the Chippewa River. It's an electrofishing survey. For those of you who are not familiar with electrofishing, that basically allows us to stun the fish to collect them. It's one of our primary collection methods for fish surveys. Basically then we can take our biological data from those fish. If you can see the boat in the lower right-hand portion of the screen, you can see these large booms coming out of the boat. That's the anode, that's where electricity comes out, and it circles back to the hull of the boat, which is the cathode. There's a generator in the boat that supplies electricity, and then a control box that allows us to control the amount of electricity that goes into the water. So we have 3 primary surveys in the lower Chippewa River. We try to do those annually. We divide the river up into kind of an upper, middle, and lower section. The first upper section is in Eau Claire. It's basically from the Dells Dam downstream to the I-94 bridge. In each survey, we shock one bank of the river going downstream. Then we the middle section of the river is the Durand site. This site is from a location called 9 Mile Slough all the way down to the Highway 10 bridge. This is about a 7-mile stretch of river that we electrofish. And additionally, our last site in the lower portion of the river is from Ella down to Nelson. This is about a 10-mile electrofishing stretch. Basically, once you jump in the river on the lower Chippewa River, you come out at Nelson because there's no other spot to come out at. You're in the Tiffany Bottoms. So in each of these 3 locations that we routinely sample on the lower Chippewa River, the habitat varies quite a bit in the upper, middle, and lower sections. The upper section, like I said, is dammed fairly frequently. So the upper section of the river is sediment starved. So we don't see a lot of fine substrates in that portion of the river. A lot of rock, a lot of cobble. The middle section of the river has probably the most diverse habitat. It has a lot of rock, cobble, along with your finer substrates, your sand, gravels, things like that. And the lower section of the Chippewa River is mainly a sandy substrate, a shifting sand bed load, and the only type of hard habitat you see in that lower part of the river is, of course, woody habitat. So it's very diverse. Your fisheries change in each of these sections of the river. What the fuck?
Okay, we've lost the
Melissa, are you there?
slides.
Looks like we've lost Melissa. Joseph, are you still with us?
I am, yep.
Okay, let me get your presentation up. Be just a second.
Okay.
There's always a plan B.
Of course.
Hey, Bob, I think we jinxed it because we were talking about how well technology was working.
I'll take full responsibility.
Okay. And unfortunately, I don't know how to make you have access to this. So do you want to tell me when you want to?
Sure, we can do that. There's
Yes.
let's see.
Tell me when to get.
Yeah, we're right. Oh, go back. One more. There we go. We can stick on this slide here. All right. So like I was saying, the habitat is fairly diverse based on these three different sites that we sample. So we see kind of a different fish community in each of these locations. Just some overarching observations from our surveys. The shorthead red horse is the most common fish species that we see in all of our surveys. And we'll take a look at that species here shortly. Some fairly common game fish that we encounter throughout our surveys are smallmouth bass. These are fairly journalist species. They're common throughout all of the sites. Probably the most sought after game fish on the lower Chippewa River. Walleye, additionally common throughout each of the sites. And muskie, these are more common upstream in Eau Claire because we've been doing some stalking, which I'll talk about that shortly. And additionally, sauger, these are more common downstream in the Ellis site, likely due to the influence of the sauger population in the Mississippi River. And we see quite a few threatened and endangered species fairly regularly. Blue sucker, river red horse, and crystal darters. These species are mainly most common in the Durand location, and this is likely due to that kind of more complex habitat there, that kind of balance between fine and soft substrates. All right, next slide, please. All right, so this is a portion of the talk. We're going to just take a quick look at each of these species. I by no means am a fish ID expert, but I will do my best to kind of give you guys some tips and tricks to ID some of these species that look alike and that we routinely see on the lower Chippewa River. So this is one of my favorite species that we encounter. This is the blue sucker. The lower Chippewa River, the Mississippi River, and lower Wisconsin River are only rivers in the state that have blue sucker populations. And we're fortunate on the lower Chippewa River to have a fairly healthy blue sucker population. We routinely handle anywhere from 15 to 40 blue suckers in a given survey. You can see these fish are very uniquely shaped. They have a head that's very aerodynamic, which enables them to sit in very fast flows and currents. These fish like very fast riffles where they can scrape algae and bugs off the rocks. So this is a pretty good sized specimen here. This is probably about an 8-pound fish. They do get up to be, say, 10, 12-pound range. That would be a very large one. They have a very neat coloration to them. They have that bluish hue, kind of some pink tones to it as well. So the blue sucker, very neat fish. Like I said, a state-threatened fish. Next slide. All right, here's a guy that kind of flies under the radar a little bit. This is the moon eye. We don't see those upstream of the Dells Dam in Eau Claire, kind of similar with blue suckers. Just downstream, they serve as a great forage for many larger game fish in the lower Chippewa River, such as muskie and northern. They get up to be about 12 inches in length. They like to feed on the surface. So on a calm day, if you see a lot of dimples on the surface of fish feeding, that's likely moon eye on the lower Chippewa River. Actually, the fly fishermen has figured this out. So there's actually a kind of a small community of anglers that like to fly fish the lower Chippewa River for moon eye. That's a fairly unique species. Next slide. All right, this is the shorthead red horse. Like I said, one of the most common fish species we see in the surveys. They common throughout the lower Chippewa River. They have a fairly small head relative to their body size. It's kind of tough without comparing it to other sucker species, but we'll take a look at those here shortly. One way to help ID suckers, especially red horse suckers, is if they have, say, color in their fins, in their caudal fin or dorsal fin, they will not have color in the first part of their name. So if you look at this as a shorthead red horse, and it has red fins, red dorsal fin, red caudal fin, so it doesn't have color in the first part of their name. Serves as a great forage for muskie and northern in the Chippewa River, very common in the upstream impoundments as well. Next slide. All right, golden red horse, another very common species that we encounter. So the golden red horse here, average size of one of these fish is around 14 to 16 inches, but they can get up to be, say, 20 inches in length and about 4 or 5 pounds. The golden red horse, you can see it does not have colorful fins for the dorsal and caudal fin. They're slate in coloration, so we do have color in the first part of the name. One way to identify a golden red horse from a silver red horse, they look very, very much alike. That's my very next slide, is by the lips of the fish. We can see on the right-hand portion of the screen that the lips have an obtuse angle to them. So if you push the lips together, they will form an obtuse angle, whereas the silvers have an acute angle. Also, the golden red horse has a slightly concave, or I'm sorry, convex dorsal fin here, from the leading margin of the dorsal fin to the rear margin. If we look at the silver red horse in the next slide, we can see that if we look at the lips here, they form more of an acute angle than the golden red horse. They are in these two photos, the silver red horse is a lighter in coloration, but coloration isn't necessarily the best indicator of a species, because color can vary for many different reasons. Silver red horse tend to be a little deeper bodied than golden red horse. And additionally, the dorsal fin is slightly concaved on the silver red horse. Very common fish in the Chippewa River and its impoundments. When folks go sucker fishing, they generally are likely catching one of these three species: the silver red horse, golden red horse, or a shorehead red horse on the lower Chippewa River, because we don't have very large white sucker populations on the lower Chippewa River. All right, next slide. This is another pretty common species that we see. They can occur locally in pretty high densities in some locations. When we're electrofishing, we'll see 20 or 30 well up at the bow of the boat. But this is the northern hogsucker. They are fairly mottled on their back, pretty unique looking fish. A large one is about 12 inches in length, so they are quite a bit smaller than your red horse species. And but average size is probably about 8 to 10 inches. If you pick them up, they'll extend the sucker out of their mouth and they'll make a little bit of a sucking noise. But another great forage species for many of the game fish in the lower Chippewa River. Next slide. All right, moving away from some of our sucker species, we'll look at the smallmouth buffalo. This is a native species, just like the ones we talked about earlier, but it often gets confused with a non-native species, the common carp. As you can see, the coloration is quite a bit different than a common carp. Common carp is really gold, has a gold yellow hue to it, whereas smallmouth buffalo have a blue or slate colored blue look to them. They actually have a real pretty coloration. These fish are fairly common in the lower Chippewa River, but not nearly as common as they are in the Mississippi River. They are so common in the Mississippi River that there's actually a commercial fishery for these smallmouth buffalo in the Mississippi. But we do see a handful in each of our surveys each year. Next slide. All right, looking at two of our native lamprey here in Wisconsin. We're going to check out the chestnut lamprey here, and the next slide is the silver lamprey. Chestnut lampreys, they will parasitize on fish, but they won't kill them like sea lampreys in the east part of the state. And the best way to identify the difference between your chestnut lamprey and your silver lamprey is if you look on the right-hand portion of the screen, and if you look at the teeth that are lateral to the mouth, they're bicuspid, or basically they got 2 points for one tooth. So if you pull a lamprey off of a fish and it's got 2 points on one of the teeth that are directly lateral to the mouth, then it's a chestnut lamprey. Easy way for me to remember that is chestnut's a compound word, so that's an easy way to remember. There's 2 points on one teeth. Chestnut lamprey, they can get up to be about a foot long, but an average sized chestnut lamprey is around 8 or 10 inches, so they don't get nearly as big as, say, sea lamprey. Next slide. So this is the silver lamprey, another native lamprey species in Wisconsin. And so they typically aren't quite as large as chestnut lamprey, but they can get to be 10 to 12 inches in length as well. But silver lamprey have a unicuspid tooth next to their mouth, unlike the chestnuts that have the bicuspid teeth. So that's the best way to tell your two native lamprey apart. There are a few more native lamprey in Wisconsin. The the northern brook lamprey and the American brook lamprey, but those are mainly in our stream systems. Next slide. This is a species that we see sometimes in fairly high abundance, the gizzard shad. This is an adult gizzard shad right here. Gizzard shad, you can ID a gizzard shad. The best distinguishing trait is this long rear edge of their dorsal fin here, this long fin ray. Sometimes that lays down right against the back of the fish, so it's tough to see. But if you see that big long fin on the back of the fish, it's a gizzard shad. They also do have a spot near their gill plate here. This one is fairly faded because it's an adult, but the juvenile gizzard shad has a much more prominent spot. And the Chippewa River and Wisconsin itself is basically on the kind of the northern edge of the gizzard shad's range. They're much more prevalent in the southern part of the country. So often we'll see large gizzard shad die-offs in the lower Chippewa River, Mississippi River as well. These are mainly comprised of young year gizzard shad and age 1 gizzard shad, just because they can't handle the thermals, the cold winter temperatures that we experience here in Wisconsin. But they serve as a great forage as well, especially the younger ones for many of our game fish species in the Chippewa River. Next slide, please. Here's a species that doesn't get a whole lot of respect in a lot of Wisconsin rivers. This is the freshwater drum, or better known as the sheephead. They're pretty common in most of our rivers, larger rivers throughout the state. They can survive in some fairly degraded conditions. But one thing that makes a freshwater drum unique is their large otoliths. So an otolith is the ear bone of the fish. They use that to feel or to hear underwater or feel vibrations. So freshwater drum have large otoliths. As you can see in my hand there on the right hand side, those otoliths are about the size of a quarter. Just for perspective and comparison, a walleye otolith is about the size of a grain of rice. So these otoliths are quite a bit larger. Why, you might ask, why say fisheries professionals care about otoliths? This is because we can get a fairly accurate age on most fish by looking at the otolith. So we can cross-section the otolith. That's the section on the picture on the lower right-hand section of the screen. Cross-section the otolith with a low-speed saw, and then count the rings on the otolith, or annuli on the otolith. And that gives us fairly accurate estimate of the age of the fish. So basically, just like rings on a tree, when growth slows, it lays down one of those annuli, and we just count those, and can have a fairly accurate estimate of the age. Some freshwater drum have been aged out to over 40 years. They can get up to be over 20 pounds, so it can be a fairly old, large fish. And because these otoliths are so unique in kind of shape and just the way that they look, people have made jewelry out of them, so earrings, pendants, things like that. So something pretty interesting fish that we have in the lower chip here. Next slide. Let's see the quillback. This is a pretty common fish that we see. Routinely handle 40 to 50 of them in a survey. The quillback looks a lot like the carp suckers that are also fairly prevalent in a lot of our large river systems. The best way to tell a quillback from a carp sucker is by looking at the lower lips. You'll see my next slides are of carp suckers, and they will have a small protrusion at the on their lower lip there. But quillbacks can have a fairly long leading edge of the dorsal fin there, a fairly long fin ray there. They're quite a bit deeper bodied than the red horse suckers, so that's one easy way to distinguish between red horse sucker and quillback. And typically, if you lay the leading edge of that dorsal fin down, it will not go past the lower edge of the dorsal fin, or the rear edge of the dorsal fin. I know it's difficult to see on this picture because that rear edge of the dorsal fin is laying against the fish, but typically they won't. Next slide. So this is a river carp sucker. It looks quite a bit like the quillback that we saw earlier, but if we look at the lips here, we can see that small protrusion out from the lower lip there. So that distinguishes the carp suckers from the quillbacks. And if we look at the leading edge of this river carp sucker, the dorsal fin there, it's fairly short. It generally never extends past the lower edge of the dorsal fin, which you can see that a little better in this photo as well. You can see it's a fairly long dorsal fin. Next slide. So we look at the high fin carp sucker here, the close cousin of the river carp sucker. We can see the big difference there is the leading few fin rays of the dorsal fin are very long. That's how it gets its name, obviously, the high fin carp sucker. And if we lay that those leading edges of the dorsal fin down against the fish, it generally does extend past that rear edge of the dorsal fin. Also, we can see that this fish does have a protrusion from its lower lip, signifying that it is a carp sucker. So we do see these from time to time, not extremely common, but we typically handle 1 or 2 in a survey each year. Next slide. All right, this is pretty neat species. This is a state threatened species here. This is a river red horse. This is one of the biggest red horse species that we see in the lower Chippewa River. This is probably about an 8 or 9 pound specimen here. They can get slightly larger than that, 10 or 12 pounds. They have big blocky heads on them. They can get up to be, say, 36 inches long, large fleshy lips on them, as you can see the picture in the left-hand side there. We routinely handle quite a few of these, probably 20 to 30 in a survey. So even though they are a state threatened species, there's a fairly healthy population in the lower Chippewa River, which is great to see. There is a species called the greater red horse that looks extremely similar to the river red horse. We don't see many of those in our survey, so I don't have a photo of those. Next slide, please. All right, this is one that many anglers may be familiar with. This is the emerald shiner. They're very prevalent in lower Chippewa River and its impoundments further upstream. They'll typically be in schools of a few hundred on the surface. And they're great forage for many different species in the Chippewa River. They don't get very large. About 4 inches is the longest that they'll get. But many anglers may know them as being sold in bait stores as lake shiners. So important small species that we have here in the lower Chip. Next slide, please. All right, the white bass. Typically, we see more white bass the further downriver we get. This is likely due to influences from the Mississippi River white bass population. They're a mid-level predator. This is probably an average size, about 12 inches. They can get up to be about 14 inches in length. Like I said, not real common upstream, a little more common downstream in the Durand and Ellis site that we sample, but we really only handle a few of them each year. Next slide, please. The long-nosed gar, this is a pretty neat species to see, very prehistoric looking. This is an average size fish at about 30 inches in length, but they do get to be fairly large, up to 50-55 inches in length. We tend to see them more so in the backwater areas of the lower Chippewa River. Some of the sloughs, they like that kind of backwater habitat, quite a bit of aquatic vegetation they like for habitat. Anglers will fish for long-nosed gar, hook and line. They typically don't use your regular lures that an average fisherman would use with hooks on them because their mouth is extremely hard and bony. So the hooks won't penetrate their hard bony mouth. So what anglers use are lures with big loops of yarn on them. So when the fish hits those loops of yarn, their mouth and teeth become entangled in those loops, which will allow them to be caught. So a pretty neat species. A little more common further downstream on the Chippewa River, especially you get in some of those backwater areas further downstream, the Ella area, the Tiffany Bottoms area. Next slide, please. So then, yeah, they have a very close cousin here, the short-nosed gar. These are typically found in the similar locations as long-nosed gar and backwater areas. As you can see, their mouth is not nearly as long. They do get to be fairly large as well, 45, 50 inches in length. But this is an average size fish in about mid 20 inch range. But these fish are much more common in the lower Chip, likely due to influences of the Mississippi River and more backwater area further down in the Chippewa River we go. Next slide. All right, most of you guys probably know this species right here. This is the walleye. They're fairly modest populations, lower Chippewa River. Pretty highly sought after by anglers. There's probably some anglers out there today because the lower Chippewa River walleye game fish season doesn't close like they do on inland bodies of water, since it is a tributary to the Mississippi River. There are some nice walleyes to be had in the lower Chippewa River. They're fairly common throughout, but fish in the 6-7 pound range are not uncommon. We do get to see some of their close cousins, the sauger, which is on my next slide. And we tend to see sauger closer down to the Mississippi River, likely due to the influence of the Mississippi River sauger population. We can see sauger, they don't get to be as large as walleye. Your fairly large walleye would be 6, 7, 8 pounds. For sauger, if you can get a 3, 4 pound sauger, that's a pretty good size sauger. Sauger are much more mottled throughout their sides, and they do have the spots on the dorsal fins. They typically won't have the white spot on the lower end of their caudal fin there. Additionally, though, to make it even more difficult to distinguish between these two species, they can hybridize. They can spawn and form saweyes together. And actually, about 2 years ago, an angler called me and thought he had caught the state record sauger. Actually, his 6-year-old daughter had caught the fish. So he brought the fish in, and after looking at it, and unfortunately it ended up being a saweye. It's about a 7 pound saweye, and so we couldn't give the little girl the honor of having the state record sauger, but it was a neat fish to see nonetheless. Next slide, please. So smallmouth bass, like I said, pretty highly sought after fish in the lower Chippewa River, probably the most fished for species. They're pretty common throughout the lower Chippewa River. A little more common, I would say, in the Eau Claire area, just due to the rocky substrate that we see. Fairly prevalent, handled quite a few throughout each of the surveys, 40 or 50 throughout each survey. A lot of nice ones out there as well. A lot of fish in the 16 to 18 inch range, with some fish like this one in the 20 inch range. So a lot of nice smallmouth in the Chippewa River. Next slide, please. Northern pike, another pretty common species we see. Typically when we encounter some aquatic vegetation in our surveys, if we're in a backwater area somewhere, we'll stumble upon a few northern pike. Like I said, not a real common species just because we don't have the habitat, the aquatic vegetation, the habitat that northern pike like in the lower Chippewa River, but still I wouldn't say necessarily uncommon. Next slide, please. All right. So the musky fishing in the Chippewa River has taken off in the past, about 4 or 5 years. It's been known to produce some fairly large fish lately. We've been stocking muskie in Eau Claire for about 8 years now, and we hope to expand that downstream to the Caryville and Durand area on the lower Chippewa River. We've been seeing some great results, some big fish, great growth rates. You can see this fish has a Floyd tag in it. If you see, that's what I'm holding on the right-hand portion of the screen there. So this is a little kind of it's a T-bar anchor that has a unique number on it that allows us to say track this fish over time if we recapture it. So this fish was about 36 inches long when we captured it in 12 pounds. I think we captured that fish 2 years prior to when we put that tag in it, and the fish was about 24 inches and 4 pounds. So we're seeing some great growth rates in the muskie that are in the lower Chippewa River, and it's likely due to the great forage that we saw with all those red horse species, those northern hogsuckers, moon eye, that these muskies can forage upon. Next slide, please. Crystal darters are state endangered species. Basically, the only other location you can find crystal darters in the state of Wisconsin is in the lower Chippewa River. In past surveys, we'd only encounter these once every 2 or 3 years. They were fairly rare. Then we kind of were able to hone in on some of the habitat they seem to prefer. They seem to prefer the downstream end of point bars, kind of that real coarse sand or small gravelly habitat. And we've been pretty successful at capturing these crystal darters. Lately, some surveys we've captured up to 30 crystal darters. So this is a fairly large darter species. This gets up to be about 6 inches in length. So the one in my hand there is a fairly large specimen of a crystal darter. And they get their names because their body is fairly translucent. You can see through them kind of like a crystal. So pretty unique fish, pretty fortunate to have a water body that can hold a crystal darter population here in the lower Chippewa River. Next slide. And certainly we do, the Chippewa River has its channel catfish and flathead catfish populations, just like most rivers throughout the state. Channel catfish are fairly common throughout the lower Chippewa River and its impoundments. Typical channel cat that we handle is only a few pounds, probably 3 or 4 pounds, but they can get up to be in the 15 to 20 pound range. Some of our bigger catfish that we see are flathead catfish, which is on my next slide. Flathead catfish can get up to be fairly large, and it's really a fishery that I think flies under the radar here on the Chippewa River and its impoundments. Certainly, this is one of the top level predators in the river system, native species, obviously, and they can get very large. The picture on the left is of a fish a little over 40 pounds that we captured in a fyke net on Lake Wissota. That large impoundment that I showed you earlier. But the lower Chippewa River does hold, lower end holds some nice channel cats or flathead cats as well. Fish in the 15 to 20 pound range are present. I wouldn't say common, but they certainly are present. So pretty neat fish to have out there. Next slide. So the last portion of my talk, I'll kind of dive a little closer into our sturgeon populations here in the lower Chippewa River, both shovelnose sturgeon and lake sturgeon. So these species do look fairly similar when they're young, but they distinguish themselves fairly early on. Lake sturgeon get to be quite a bit bigger than shovelnose sturgeon. Large shovelnose sturgeon will be in the 8 pound range. 10 pounds would be very large. 30-inch shovelnose sturgeon is a fairly large one. They have a very narrow caudal peduncle, which is the area just ahead of its caudal fin or the tail fin there. That gets very narrow, where lake sturgeon's caudal peduncle is a lot fatter than that. Shovelnose sturgeon has a fairly flat head, shovel-like. That's how they got their name. Their coloration is generally a lot lighter. See that kind of tan coloration. They kind of blend in with the sand. They're sometimes termed sand sturgeon or cacklebacks, I've heard them called as well. And additionally, their barbels is, you can see the barbels in the left-hand portion of the fish's whiskers. Those are serrated, whereas a lake sturgeon has straight whiskers. And then the shovelnose sturgeon's mouth is split into 4 different lobes. Whereas a lake sturgeon is 2 different lobes. So next slide, please. So the Chippewa River does have a fairly healthy lake sturgeon population. Lake sturgeon in the lower Chippewa River average around 30 to 40 pounds, but we have captured fish close to that 100-pound range. So there are some fairly large lake sturgeon out there. As we can see, lake sturgeon are a lot darker in coloration, generally that really gray to a black color in them. Their head is a lot more round than the shovelnose sturgeon. Then, as I mentioned, their barbels are straight and their mouth is split into 2 lobes instead of 4 So once they get fairly large, they're easy to ID because really shovelnose won't get larger than 8 or 10 pounds, where lake sturgeon get quite a bit larger than that. Next slide, please. So right now we're going to take a closer look at the shovelnose sturgeon population. As I talked about earlier, the shovelnose sturgeon in the early 2000s experienced some fairly dramatic declines. So we figured we'd take another look at the shovelnose sturgeon population this past year in 2019 to see what that looked like. And that's kind of what this portion of the talk will focus on. Next slide, please. So just look at a map again. I think if you can, let's see, if you advance the next slide, it should highlight a portion of the map there. Yep. So this is the portion where this survey took place in. It's called the Meridine Slough. It's a 4.5-mile stretch of river where a spawning population was located. But we can see Eau Claire is kind of in the upper right-hand portion of the map there, and you can see the Mississippi River in the lower portion. So this is the whole lower 60 miles of the Chippewa River that we're looking at. Next slide. All right. So there's been quite a bit of work done with shovelnose sturgeon in the lower Chippewa River in the past. Lyle Christensen in the early 1970s did some shovelnose surveys from where the Red Cedar River dumps in to the Chippewa River all the way down to Durand. He calculated a population estimate of around 2,300 to 2,700 fish, or about a catch rate of 20 fish per mile. He tagged these fish, so he was able to get some information about the movement of the shovelnose sturgeon, and he calculated the average movement of these fish was just a few miles upstream, about 3 miles upstream, and 4.7 miles downstream. So they really didn't move a whole lot. Then in the late 1990s, some of Lyle Christensen's data was worked up a little more, and they figured the average home range of a shovelnose sturgeon was 2.1 miles. Next slide, please. So then in the, like as I mentioned during FERC licensing in the early 2000s, there's quite a few fishery surveys done. Over 280 river miles were electrofished through 65 different surveys, and their catch rate was only about a half a shovelnose sturgeon per mile. So very low, quite a bit lower than what Lyle Christensen saw in the early 1970s of 20 shovelnose sturgeon per mile. So this was, fairly alarming here to see this, and certainly some speculation was had that perhaps this could be due to commercial fishing on the Mississippi River. Advance the slide. So then in the early 2000s, there was a little more extensive of a movement study done just to see if this was the case. So 12 shovelnose sturgeon were telemetry tagged with radio tags, and it was found pretty much the same thing that was observed in the 1970s, that these fish didn't move around a whole lot. Their home range was about a half mile, and the movement between the Chippewa River and Mississippi River was extremely limited. So basically, we can consider these two stocks separate. Next slide. But due to these concerns about the decrease or decline of the shovelnose sturgeon population, the hook and line season was closed on the lower Chippewa River in 2004, and it remains closed to this day. So there's no, you can't target shovelnose sturgeon in the lower Chippewa River. Next slide. So then in 2006, a spawning concentration was located on the lower Chippewa River at that location that I mentioned earlier, the Meridine Slough, 4.5-mile stretch of river. And then in 2006 through 2011, population estimates were done in that area. And each survey came back fairly similar, around 1,300 to 1,800 fish. So the population was deemed stable at that time. So that was good to see. Next slide. So then we figured there hadn't been any work done with the shovelnose sturgeon population since 2011. We figured let's jump back in and see if we can get an update on the status of the shovelnose sturgeon population in the lower Chippewa River. So we electrofished that same area, the Meridine Slough, in mid-June of last year. We had 6 different sampling events during that time frame, And the water temp was in the mid 60-degree range. This is prime shovelnose spawning temperature. And the way we captured these fish were we zigzagged downriver, and then when we located a spawning concentration of fish, we focused on that area until catch rates dried up. And then we just continued on downriver. Advance the slide. So data that we collected was fork length, sex of the sturgeon. We also tagged it if it didn't already have a tag in it, or we gave it or we recorded the information that the tag information the fish had. Additionally, we took a subsample of weights, and we did collect some pectoral fin rays for aging. We did get enough recaptures to calculate a population estimate as well, so we can compare that to previous surveys. Next slide. So it was a fairly enjoyable survey. You're on the river. Temperature is generally pretty nice out in early to mid-June. Not a lot of other people on the river. Next slide. And it's always nice when you do a fisheries survey and the fish cooperate. So we captured quite a few fish during this survey. Catch rates each day were as high as 300 shovelnose sturgeon in a day. Next slide. These fish are, this was my first time working extensively with shovelnose sturgeon. Very neat fish, very prehistoric looking fish. Feel fairly privileged to be working with a species like this. Next slide. We can see you can see a little bit, the barbels on this fish, as I mentioned earlier, are serrated, especially on that top barbel in this picture. And also you can see the different lobes in the shovelnose sturgeon in this photo. Next slide. So we encountered quite a few fish in this survey. About 1,200 different unique fish, and typically when you encounter a lot of different fish, you're going to encounter some with some abnormalities. We encountered a handful that were missing its caudal fin, like this fish. We called them stubbies. But despite the missing of the caudal fin, they appeared to be in fine condition. Next slide. For comparison, this is what the caudal fin of a shovelnose sturgeon is supposed to look like. They have a fairly long whip that extends out from the end of their caudal fin there. Can be up to 6 inches in length, but oftentimes it's broken off. So that's why we take fork length on these fish, which is a length measurement from the furthest fork of the tail, or furthest closest to the head of the caudal fin there. Next slide. But we did, like I said, encounter some fish with some other abnormalities. This fish had quite a substantial missing portion of its shovel. Next slide. And this fish had quite a large, looks like a bite or portion of its shovel missing as well. This was not very common, but everybody kind of likes to see photos like this. And like I said, despite these abnormalities, these fish were doing fairly well. They were in good condition. It didn't seem to affect them much. Next slide. So let's getting back to some of the numbers from this survey. We look at our left-hand column there. Those were the dates surveyed. The second column is the number of fish that we captured each day. So we can see it ranged from about 75 fish to well over 300. The middle column is the number of fish that we recaptured in each of the surveys, which is essential to calculate a population estimate. The next column is the number of marked fish that each day, and the last column is the total marked fish at large. So next slide. So our population estimate came back quite a bit higher than previous surveys, about 7,700 shovelnose sturgeon. This came back at about, our catch rate was about 50 fish per mile. This is twice of what Lyle Christensen saw in the early 1970s, and quite a bit higher than what was seen in the early 2000s. Next slide. Our sex ratio of these fish were, the majority were males, about 79% males. We had about 4.4% females, and of course we had some fish of an unknown sex. But this sex ratio likely isn't the true ratio that's out there. This is male shovelnose sturgeon, just like male species of a lot of different fish. They'll come to the spawning grounds early. and leave the spawning grounds late. So they'll be there for the whole duration of the spawn, whereas female shovelnose sturgeon come in, lay their eggs, and then leave. So male shovelnose sturgeon are just a lot more vulnerable to our survey. And one interesting thing was that we captured 72 shovelnose sturgeon that were tagged from 2006 through 2011. So this yields some interesting growth data. Next slide. So this is the length frequency of the shovelnose sturgeon that we captured in this survey. The mode for this was around 26 inches, 26.5 inches. Next slide. And so we started seeing males mature around 21 inches in length and females around 24. Next slide. Which is similar to what we saw in other surveys as well. So how does this size structure compare to the previous surveys? Well, in the early 1970s, it was slightly smaller. Their mode was around 24.5 inches, and in the late 2000s, it was slightly larger, right around 27.5 inches. But all in all, the size structure of the population is pretty stable. Next slide. So like I mentioned earlier, one very interesting thing is that we captured quite a few fish that were tagged from the surveys conducted in 2006 through 2011, 72 to be exact. So on our left-hand side there on our y-axis is our growth rate in tenths of an inch, or growth in tenths of an inch, I should say. And then our x-axis is years between captures. So those fish were at large from anywhere between 8 and 13 years prior to us re-encountering them in this survey. So if we look at some of their growth there, so this isn't the growth per year, but this is the growth while the fish were at large. If we look at some of these fish that were large for 9 or 10 years, those fish grew less than 2/10 of an inch in 9 or 10 years. So these fish are growing extremely slow. If we look at some fish that were at large for 13 years prior to us recapturing them in 2019 here, those fish grew about 9/10 of an inch in 13 years. So we're seeing some very slow growth, but this is common. They see this slow growth on the lower Wisconsin River as well. So likely these fish grow fairly quickly until they reach maturity, which for shovelnose sturgeon, for males, that's about age 5, and females about age 7. Once they hit maturity, they really put all their energy in developing those eggs and melt and not in the growth. So that's likely the reason why we see very slow growth here. Next slide. Oh, back one, there we go. So when you have such slow growth, you start to wonder, are we really seeing slow growth here, or are we just measuring, or is this measurement error? Because when these fish are squirming around, it'd be pretty easy to mismeasure a fish by 1/10 or 2 or 3/10 of an inch. But fortunately, we were able to get at that. We had some measurements on 92 fish multiple times, so we can calculate how accurate we were at measuring fish. And we were well within about 1/10 of an inch, so some of the growth that we saw was indeed true growth. Next slide. So we look at the ages of some of the shovelnose sturgeon that we encountered. These are age estimates. We estimated the ages from about 6 to 15 years old. And this is likely a drastic underestimation of shovelnose ages here. We know when these fish grow very slow that those annuli, or they get laid down fairly about on top of each other on the edge of the fin, right? So they become very difficult to age. Basically, those rings are just laid down on top of each other. Additionally, we know that some of those fish were out there for at least 13 years at large, and those fish were at least 5 years of age when they were initially tagged, so they're at least 18 years of age, and certainly we didn't age any fish over that long. These growth measurements are fork lengths. Next slide. So some conclusions from our shovelnose sturgeon survey here. We saw a substantial increase in the population estimate, threefold from the early 1970s, sixfold from the later 2000s. Continue on. And however, due to uncertainty in aging, we don't know whether these are new young fish in the population or older fish that were just not sampled in previous surveys. I suspect these are older fish that weren't sampled in previous surveys. But hopefully if we get some results from some more of our recaptured fish that'll yield us some better age estimates. Next slide. We determined that growth was very slow, far less than 1/10 of an inch per year, more on the lines of a 100th of an inch per year. Next slide. And certainly we'd like to repeat the survey to see if we can duplicate these results. Next slide. So some conclusions and management implications that we can draw from this. We'd like to, like I mentioned earlier, we'd like to collect some more aging samples, especially from those fish that were tagged from 2006 through 2011, because we know those fish will be at least 13 to 18 years of age. And then we can see how our fin rates compare to that, or our age estimates compare to that. Next slide. And then if the population sustains itself or increases, perhaps we could look at opening up a conservative hook and line season in the future, but we would need quite a bit more data to be able to justify that. All right, so that that kind of does it for the shovel nose portion of my talk. But now I'm going to jump into the lake sturgeon portion of my talk, and I see I'm running a little short on time, so I might try to fly through a few things here. So we do quite a few lake sturgeon assessments each year on the lower Chippewa River. We do a gill netting survey downstream of the Dells Dam. We also do a dip netting survey during active spawning at Jim Falls. We do try to get out and do a hook and line survey downstream of Dells Dam as well, and this is a juvenile assessment because it's really the only way we found to be able to capture juvenile lake sturgeon. We do collect some data from the hook and line season, and we have a fairly large movement project that we're hoping to launch this year. Next slide. All right, so jumping in to some of the hook and line data from this year and years past. Just a little background on the season. You can keep one fish per year. The season runs from the first Saturday in September to September 30th. There's a 60-inch minimum size limit. Next slide. Which has been in place since 2007. And then we do have a mandatory in-person registration. So moving forward to the next slide, we can look at the harvest of lake sturgeon lower Chippewa River since registration became mandatory in 1983. There's been various size limits since that time frame. We can see when there was a 45-inch size limit, harvest was still increasing, still with a 50-inch size limit. We could see sturgeon harvest in the lower Chippewa River, which runs from Lake Holcomb all the way down the Mississippi River, which is about the lower 100 miles, topped about 100 fish in 2001. And then lake sturgeon harvest started to drop. Certainly there was some concern that overexploitation was happening in the population. So a 60-inch minimum size limit was implemented in 2007, and it's been like that ever since. So that substantially reduced harvest. Now we see an average about 11 lake sturgeon harvested annually on the lower Chippewa River. We do see that trending upward, and that's likely due to these lake sturgeon growing into that larger minimum size length limit. Next slide. So some of the survey we collect from these fish are biological data, length, weight, and sex, tagging information. So some of these fish are pit tagged with pit tags, which I had mentioned earlier, which is the same little microchip that folks put in their dogs and cats to keep track of them. They don't have a battery life. They're energized by the reader, which you can see in the lower left-hand picture. We insert those pit tags underneath the skull plates of the fish. And when we capture a fish with a pit tag in it, sometimes it has some pretty interesting capture histories. Next slide. Continuing on. So we can just kind of rattle through a few of these slides in fairly rapid succession here. This is some gill netting downstream of Dells Dam on the Chippewa River. Next slide. When we get fish in the gill net, we untangle them from the gill net. Next slide. Put them in a net pen. Next slide. Take our length measurement. Next slide. We weigh the fish. Next slide. Scan them for the presence of a pit tag, and this is the fish downstream of Dells Dam can have a fairly interesting capture history because we've captured fish from the Mississippi River, from the St. Croix River, from the Wisconsin River. So these fish are moving all over the place. So when we do get a recapture of a fish on the lower Chippewa River below Dells Dam, we're pretty excited to look up the information from that fish. Next slide. So one of our biggest lake sturgeon surveys happens at Jim Falls which is the furthest upstream dam of Lake Wissota. So this is the largest impoundment on the lower Chippewa River, 6,300 acres, has a fairly sizable lake sturgeon population. Next slide. So this is kind of our setup there. Like I said, these fish are actively spawning, so they have one thing on their mind at that time, and that's spawning, and they don't really realize that we dip them in a dip net until it's too late. Next slide. So this is a spawning concentration of fish. You can see these fish are tailing. Their caudal fins are up in the air. This is a spawning concentration of about 10 or 12 fish. There can be spawning concentrations as high as 30 or 40 fish at this location. Next slide. So basically those fish aren't aware, but we just we net them up and they really don't know what's going on until we get them in the net. Next slide. And we collect biological data from those fish as well. This is a fairly substantial, fairly sizable fish that we caught in 2017. This is about a 70-pound fish. Next slide. We were able to top that in 2018, and this fish was about 85 pounds. And then last spring in 2019, next slide, we captured the largest lake sturgeon that we have record of on the lower Chippewa River system. This is a 98-pound fish. It's just over 72 inches in length. So very large fish, very old fish, tough fish to age. So it's tough to get an accurate age estimate on this fish. But in a typical survey at Jim Falls, we handle anywhere between 150 and 200, up to 250 lake sturgeon in a survey. So there is a fairly sizable lake sturgeon population in Lake Wissota that comes up and spawns below Jim Falls. Next slide. As I mentioned earlier, when you handle quite a few fish, you get to see some abnormalities. So this is a lake sturgeon that was a stubby. It has truncated quite a bit before its caudal fin there. But despite this abnormality, the fish seem to be doing just fine. Next slide. So one interesting thing is that we do get to see some juvenile fish. Unexpectedly, we see some juvenile fish in our spawning survey, and that's unique because there's really no reason for those juvenile fish to be in with the adult fish spawning because they're not spawning. They should be out in the lake growing, but then after collecting some of these juvenile fish, it became apparent why these juvenile lake sturgeon were there in with the spawning population. If you can see that photo in the kind of upper left-hand portion, that sturgeon coughed up this big ball of sturgeon eggs. So that was fairly unique. It was a little concerning at first, but I called my colleague on the Winnebago system, and he said they see that all the time. Nothing to be very concerned about. So next slide. And then we also do, like I said, a hook and line survey for juvenile lake sturgeon. These fish will yield some very interesting data in the future because we do give these fish pit tags. So we have a pretty good idea exactly how old these fish are at a young age. And then we can, when we recapture them 20, 30, 40, 50 years down the road, we'll have a pretty good idea exactly their growth during that time at large. In a typical juvenile survey, we'll capture between 15 and 30 juvenile lake sturgeon in a day. Next slide.
Joseph, can we wrap things up? Take some questions so folks
Sure.
get ready for the next section. I don't know how many more slides you have.
Sounds good. I just have a handful more. I'll go through them pretty quick here if that's all right. So like I mentioned earlier, we do have some very interesting movement data from some of these pit tag returns. We see these fish on the lower Chippewa River. They move down to the Mississippi River. They move up to the St. Croix River, down to the lower Wisconsin River. The furthest data that I got from a recapture is a fish that we tagged up at Jim Falls. It moved over multiple dams, likely during high water events. And that fish was eventually captured by the Missouri DNR in the Mississippi River near the Iowa-Missouri border. And so that fish had at least a 500-mile journey. Next slide. Next slide. That's just a dangler tag there. So in order to get at some of this movement work, we are going to do a big lake sturgeon movement project. We're hoping to kick it off this year. We already have some receivers out there on the river. So we're going to surgically implant 77 lake sturgeon with hydroacoustic transmitters, which is both sides of a AA battery. That's in the lower left-hand side of the screen. And we're going to have receivers out to monitor their movement throughout the tributaries of the Mississippi River. Next slide. So these are some of the locations that we'll have them at on tributaries of the Mississippi River. And there's also a large array of receivers out in the Mississippi River already that we can piggyback off of. These tags will be good for 10 years. So we'll be able to track the sturgeon movement for 10 years. And ultimately we'll be able to determine, hopefully, if there's river resident populations, such as in the Chip or the St. Croix, or if this is one large Mississippi River population. So that's what I had for you guys today.
Well, that's great. That covered a lot of water, so to speak. We are running a minute or two late. I'm checking the chat box. You answered a couple of the questions en route, so that was good. I'm just checking to see. I don't see any other questions that you haven't addressed in the chat box. So in the sake of letting our technical people get ready for the next session, Joseph, thanks very much for your presentation and your time. Appreciate that. Sorry we had some technical difficulties, but I think we recovered nicely, and hopefully everybody enjoyed the presentation. I know I did. These are amazing fish, super fun to work with, and our next session starts at 2:45, so we've got a couple of minutes before that, but just say thanks to Joseph for your time. Thank you.
Yep, thanks for listening, guys.